Hey YouTube, welcome back to another episode of Intuition. In today's video, I want to switch things up a little bit. Today, I want to go over numbers in the decimal system. So most of us have learned decimals in school, elementary school, and so forth. That's how we first learned about numbers. But how many of us actually understand what decimals really mean? In fact, decimals are really an arbitrary way of representing numbers. And in today's video, we're going to go over that and to see why that is. So in today's video, we're going to answer 3 questions on the decimal system and how it relates to other number systems. All right, so let's dive into it. Question number 1. Question number 1 states, how would the number 26 be represented in a base 5 pental number system as opposed to a decimal base 10 number system? In this question, we're being asked to represent the number 26 in a base 5 number system, which is called a pental number system. So how do we do that? First, let's make sure that we understand what a decimal system actually means. So when it comes to a decimal system, what we're doing is we're grouping numbers in bundles of 10. And more specifically, we're grouping numbers in terms of bundles of powers of 10. So what do we mean by that? With a decimal number system, the first thing we do is we put down our decimal point, and our decimal point is a reference for the bundles of powers of 10. So the first slot to the left of the decimal point represent the number of bundles of 10 to the 0 power, because this slot is in the 10 to the 0 slot. And what is 10 to the 0? 10 to the 0 is equal to 1, because any number raised to the 0 power equals 1. So this slot represents the number of ones that we have in our number. And if we go another slot over to the left, we're in the 10 to the 1 power bundles. And what is 10 to the 1? 10 to the 1 equals 10. So numbers in this slot represents the number of bundles of 10. So if there's a number 2 here, that would represent 2 bundles of 10. And 2 bundles of 10 is equal to what? 20, right? 10 times 2 is 20. And if we keep going, go over to the next slot after that, we're in the section of bundles of 10 to the 2 power. And 10 to the 2 is equal to 100. So when you take a look at the decimal system, as we move over to the left, we're increasing by a factor of 10. And if we move to the right, any slot over to the right is 10 times smaller than the slot to its left. So if we go back to the decimal point and move to the right, now we're representing numbers that are smaller and smaller by a factor of 10. So in the first slot to the right of the decimal point represents numbers that are 10 times smaller than 1. So that would be 10 to the minus 1 power. If we move over again to the right, now we're in the 10 to the minus 2, and 10 to the minus 2 is 1 over 100, so this is the number that is 100 times smaller than 1. And this is how a decimal system is built. But here's the thing, we could have chosen any other number to create our number system. We could have chosen 5, for example, which is what this problem is telling us to do. This problem is telling us to do the same thing using base 5 instead of a base 10. And specifically, we want to represent the number 26. We want to represent the number 26 in this base 5 number system. For a base 5 number system, we're going to be doing the same thing. We're going to be grouping numbers in terms of their powers of 5. So we're going to have a slot for 5 to the 0 power, a slot for 5 to the 1 power, a slot for 5 to the 2 power, a slot for 5 to the 3 power, and so forth. And when it comes to representing a number in this number system, the first thing we want to do is we want to ask, what order of magnitude in base 5 is this number? This number is the number 26. What ballpark of power of 5 is this number closest to? 5 raised to the power of 2, that's 5 times 5, which is 25, and that's very close to 26, right? That tells us that the number 26 is in the order of magnitude of 5 to the 2 power. 5 to the 2 is 25, and how much is left over from 26? 1. And 1 is equal to what power of 5? 1 is equal to 5 to the 0. Therefore, the number 26 is equal to 5 to the 2 plus 5 to the 0. The slots that will be filled for our number will be the slot of 5 to the 2 and 5 to the 0. We have one bundle of 5 to the 2 and we have one bundle of 5 to the 0. So we're going to have the number 1 in the 5 to the 0 slot. And in the 5 to the 1 slot, that's not represented, so we put a 0 there. And in our 5 to the 2 slot, we have one of those, so we put a 1 there. So this number is going to be 101. And it looks like 101, but in our base 5 system, the number 101 equals 26, not 101. Okay, let's go on to number 2. Okay, question number 2 states, TJ types the number 24 into his computer program. How does the computer store this number? Okay, so with this question, there's something that you need to know. Computers don't do math in decimals. Computers do math in binary numbers. So computers do math in base 2 instead of base 10. So the number will be grouped into powers of 2. So for this question, we do the same thing. What order of magnitude is the number 24 in terms of power of 2? Let's take a look at our powers of 2. 2 raised to the 4 is 16, still smaller than our number. So let's try 2 to the 5. 2 raised to the 5 is 32. That's too big. So the number 24 is on the order of magnitude of 2 to the 4. All right, so 2 to the 4 is 16. And when we take away 16 from 24, how much do we have left over? We have 8 left over. Okay, now we do the same thing. What order of magnitude is 8 in terms of powers of 2? 2 raised to the power of 3 equals 8. So we're done, right? Because the number 24 is going to be equal to 1 times 2 to the 4 plus 1 times 2 to the 3. So the slots that will be filled in our number will be the slots 2 to the 4 and the slot 2 to the 3. Each one of those slots will be filled with the number 1 because we have one of each of those powers, right? So this number looks like 11,000. To a computer, 11,000 is 24. So the answer is C. Okay, question number 3. Question 3 states, the number 1x.4 is written in the undecimal, which is a base 11 number system, where the number 10 is represented by x. What is the equivalent of this number in decimals? Round to 2 decimal places. So same type of problem except for this number. This number is represented in a numerical system of base 11. So with a base 11, we're going to have 10 ones. What's different about base 11 versus the other bases that we were looking at is that base 11 is a base that's greater than base 10, which is the base that we're used to. Since we're grouping numbers in base of 11, the number 10 will no longer be represented as a double-digit number. 10 becomes a single-digit number. And in this case, we're given the number 10, the single-digit representation of x. So x is just 10. And now we can go ahead and figure out what this number is in decimal system. So how do we do this? Well, let's start with the highest power. So the highest power we have here is 11 to the 1. We have one representation of 11 to the 1. And what is 11 raised to the 1 power? 11 to the 1 just equals 11. So we have 111, and then we have x 11 to the 0. Because in the 11 raised to the 0 power slot, we have x of those. So we have x 11 to the 0. And what is 11 to the 0? 11 to the 0 just equals 1. And what is x? X just equals 10. X times 11 to the 0 equals 10. So we have 11 plus 10. We have 4 in the 11 raised to the minus 1 slot. So 11 raised to the minus 1 is 1 over 11. So we have 4 1 over 11. So that's 4 over 11. So now we just need to add these numbers up and find our answer. So we have 11 plus 10, which is 21, plus 4 over 11. And 4 over 11 is approximately 0.36. So we have 21 plus 0.36, which is 21.36. So this number is equal to 21.36 in decimal systems. And our answer is answer choice A, okay? And that's how you solve these types of problems. So I hope you guys learned something about the decimal system today. It definitely helps to give you a deeper understanding of what our numerical system represents. So I hope that it was helpful. If it was, go ahead and leave a comment. If you have any questions, go ahead and leave a comment as well. As always, keep watching and keep learning. All right, bye-bye.